Welcome to my presentation. In this presentation, let us look at some more examples related to sum or difference of two cubes. Let us say we have a example in this form. We want to factor the polynomial which is of this form 64 minus x cubed, like that. Okay. So in this in here we want to see whether each one of the terms given to us is a perfect cube or not a perfect cube. So we know that let us recall some perfect cubes. Some perfect cubes. 1 cubed is a perfect cube. 1 times 1 times 1. 2 cubed is 2 times 2 times 2, which is equal to 8. So 8 is a perfect cube. 3 cubed, 3 times 3 times 3, which is 27. So 27 is a perfect cube with a base term as 3. 4 cubed, 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So therefore 64 is a perfect cube with a base term as 4. Then 5 cubed. 5 cubed is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Therefore 125 is a perfect cube with a base term as 5. And we can keep going. And you can also verify these in your calculator. If you have a scientific calculator, you have squares and cubes and all kinds of interesting features in your calculator, so you can use those use your calculator to also arrive at these. But if you know your times table, it is as simple as this. So therefore in here we're going to then come back here and then say 64 is a perfect cube, so therefore I'm going to write that as 4 cubed minus x cubed. And this is now beginning to look like the difference of two cubes. The difference of two cubes. And what do we know? The difference of two cubes, the formula we have talked about is, if we have a and b as two terms, and if we want the difference of those, the difference of two cubes like that, the way we can expand it is as follows. We write a minus b times a squared plus ab plus b squared, like that. And what we have in this given problem is this. We have 4 cubed minus x cubed, and we want to expand that. For us, a is 4 and then x is b. So 4 minus b, and then in the second set of parentheses we're going to take the first term, which is 4 for us, raise it to the power of 2, that is a squared, plus ab, 4 times x. The first term is a, first time is 4 for us, the second term is x for us, so therefore 4 times x, plus the second term is x for us, and then we need to raise it to the power of 2. Now it is just a matter of simplifying these terms. So we have 4 minus b times 4 squared is 16. 4 times 4 is 16. Plus 4 times x is 4x. And then x to the power of 2 is x to the power of 2. We cannot simplify that any further. So therefore, there should be x, not b. Right? There should be negative x. 4 minus x times 16 plus x squared plus 4x plus x squared is what we have, and that is the expansion for 64 minus x cubed. So this is how we want to use the difference of two cubes formula to be able to expand this given polynomial. In my next presentation, we shall look at some more examples and then see how we can use the procedure which we talked about to simplify problems related to sum and difference of two cubes.